Hello, this is Mrs. Taylor, and I'm going to walk you through a problem on how to minimize distance. So in this problem it says, which points on the graph of y equals 4 minus x squared are closest to the point 0, 2? And we have this graph here to kind of help us visualize where the points might be located. And it says points here, because if you think about it, if we are looking at points that are the closest distance from this point that's here on the y-axis, you're going to have two that are the same distance. And so when it's talking about closest, it's talking about distance, and that means we're going to use the distance formula. And so the distance formula is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And what we have here is we have the point 0, 2 and the curve y equals 4 minus x squared. So it's this point, which would be my x1, y1, and then this equation here, which I will use in my distance formula here. So when I plug everything in, I get distance equals the square root of x2, which would just in this case be x, whatever my x value is, minus x1, all squared plus y2, which is what y equals, which is this equation, minus y1, which is 2, all squared. Okay, so this would be my primary equation right here, because this is the equation that I'm going to use to minimize my distance, because this represents the distance from this point 0, 2 to this curve that can be given by this equation here, y equals 4 minus x squared. And so I'm going to simplify everything. And I'm going to leave this just as a binomial squared. So that would be 2 minus x squared squared. And then I'm going to take the derivatives. So the derivative of this, well, I'm going to have to use chain rule. The outer is this radical, so 1 half times the inner. And now I'm going to take the derivative of the inner. Well, my first term is x squared. The derivative of that would be 2x. And then the derivative of the second term is the chain rule problem. So the derivative of the outer, which would be 2 minus x squared. Subtract that 1 from that 1 and 2 times the derivative of the inner, which would be negative 2x. Just walking on back through that, derivative of the outer would be 1 half and the negative 1 half, and the derivative of the inner would be 2x plus 2 times the derivative of the inner times the derivative of the outer times the derivative of the inner. So yes, I know I got all that right. So now I have to find where my derivative is either equal to 0 or undefined. And so I'm going to clean this up a little bit so it's a little easier to solve. So once I've simplified everything, basically I took this 1 half and multiplied it by what was in this set of parentheses here, which would divide out 2's from each term. And then I wrote it as a rational. So this negative 1 half exponent brought it as a radical to the denominator. And now to find where my derivative equals 0, I set the top equal to 0. And to find where my derivative is undefined, I set the bottom equal to 0. Well, looking at the denominator, this is x squared, so this will always be positive. And whatever's in these parentheses is going to be squared, so it will always be positive. Therefore, the denominator will never equal 0. So I don't need to worry about that. I'm just going to take the numerator, set it equal to 0, and solve. Alright, so once I solve, I'm going to factor, simplify. It's a little bit messy, but it all comes down to this, where x could equal 0, or x could equal plus or minus square root of 3 halves. So at this point, what I have to do is test to see which one yields a maximum or a minimum, and then I would have my coordinates that would create the closest distance between the point 0, 2 and the curve y equals 4 minus x squared. So the next thing I'm gonna do is create a sign chart to determine maximums and minimums. So in order to test my values, I know that the square root of 3/2 is between the square root of 1, because 3/2 is 1.5, and the square root of 4, which is definitely greater than 1.5. And so for my test values, I can pick, for example, -1 here and -2 here. And just looking at the signs of everything, we know the denominator is always going to be positive. And then I use the factor form here to determine what the numerator would be, the sign of the numerator. And through that, I created this sign chart. And so I can see that it goes from decrease to increase, increase to decrease, decrease to increase. So I have a minimum at negative square root of 3/2 and positive square root of 3/2. And so it says which points, which means I've got to take those y values, plug them into my original equation to get the corresponding, or excuse me, take those x values, plug them into my corresponding equation to get the y values, and then I'm done. And as discussed in class, you can leave it written just like this. You don't actually have to get the numeric value for 4 minus 3/2. And so there would be the 2 points that are closest to the point 0, 2 on the curve y equals 4 minus x squared.